All right, we're coming down the home stretch here on section 4.2. And in this last section, we're going to use the models, the equations that you made. We're going to use the table that you filled out, and we're going to use the graph that you made. And here's how. So we drew, you notice that the table and the graph both contained information for both milk and soda. And even though they're separate things, they're separate equations, separate lines, we can still do something. Putting them together like this allows us to do something kind of interesting. And that thing is what we're being asked to do in number 7 and number 9, which we're going to do in a second. So what we're trying to do is find out when the milk consumption and the soft drink consumption were the same. So in other words, we're going to find one value for t, and that t, whether we plug it in to whether we're talking about milk or soda, they're going to be, people are drinking on average the same amount of these two different beverages. So there's going to be some year in there somewhere. And so we're going to start out with like t equals 8. Okay, and hint, that's not the answer. But let's say we say it's t equals 8. That would mean in 1958 that the soda and the milk consumption was the same. So we want to look at that table that you filled out, and see if you can find a value for t where they're about the same. And if you don't find the one that's exact, you can approximate to the best of your ability. And the same on the graph. We're looking for one value of t on the bottom. So remember, t is on the bottom and gallons are over here. And we want to find one value of t where the output is the same for both milk and soda. So what that means is that both of these lines need to go through this point here. Both of the lines need to go through this point because this point needs to represent both milk and soda. So we want to approximate that t there. What approximate value of t gives us this point here? And we want to go to the table and look and see what value of t gives us, because we have, milk and soda. We want to look and say what value of t gives us approximately the same value for milk and soda. All right. So for number 9, we'll skip number 8. I don't feel that's a useful question. We'll just go ahead and go to number 9. So number 9 asks us the same question as number 7. We're interested in what year do these two quantities equal each other. Well, we're going to find a value for t, and once we find the value for t, we'll use that to figure out the year, right? We can work backwards. Before we converted years to t, and now we're going to find a t and then go backwards to years. And so what we want to do now is forget the graph, forget the chart, and even though those gave us an idea of what the answer is going to be, and that's going to be useful too, we're going to go back to these two models you made, like m equals and s equals. So those are two equations, two models that you made. And what they're asking you to do, basically, is to solve this problem algebraically, which means just with equations. And we want to know when m and s are equal. We want to do something with these equations that you made. These are back in number 3, maybe, when you made these models, or 4. Oh, number 4, it tells us right there. And figure out, use those two equations to figure out what my value for t has to be to produce the same value for both m and s. The same value for both m and s. All right, well, let me do a sort of different, similar but different problem here to maybe get you going on this. So here are two equations, and these aren't milk or soda or anything. It's just good old x and y. And we're going to ask the same question. We're going to ask what value of x can I plug in here and here? So I'm choosing one value of x, and I'm going to plug it into these two completely different equations and get the exact same y in both cases. So I need an x that can give me the exact same y. So let's think about what this means. That means that this whole thing has to equal this whole thing. We're looking for an x that makes that equal to that, right? Because this is equal to y, and we want them to have the same y. So what we're going to do is use the fact that we want these two things to be equal. We're going to use the fact that we want 2x plus 6 to equal 3x minus 7. And what we're wondering is what x will make that happen, right? Because this is really y, because it says here that 2x plus 6 is equal to y, and same with 3x minus 7. So what value of x will make these two y's equal? Well, here we just have to do a little bit of algebra, right? We subtract our two x's from both sides, and we get 6 equals x minus 7. Then we add 7 to both sides, and we get 13 equals x. So what this seems to be saying is that if I plug 13 into either of these two equations up here, I should get the same output. So I'm not going to go any further with this, but what I would do, and what you should do when you're working on the milk and soda problem, is once you get this value, is say, okay, I'm going to plug it back in. I'm going to plug it first into this top equation, then I'm going to plug it second into that one, and see if I get the same thing. And if I do, then I'm probably onto something. If not, well, I better go back and check my math.